Hi, I'm Kyle Jones, and in this video, we're going to be talking about how to use machine learning to predict grid stability. The grid stability is an important task for utilities, especially the ISOs. And as more and more people look to add to the grid and pull from the grid, it becomes a really vital part of the grid modernization efforts. What we have here is a data set that's been curated by UCI and is available through Kaggle. And we're going to use Amazon SageMaker Canvas to do a classification problem and identify when the grid is stable and when it's not stable. The data is in really great shape here. This is unusual for the real world, but in this case, it's a great learning tool. So we'll take this data, and I'm going to jump right over into Amazon SageMaker. Today, we're going to use a tool called Canvas, which is a new version of SageMaker that is no code. So we don't even need code in order to build this ML model. Just going to open it up and it'll open up a brand new browser for us. I've already uploaded the data through my S3 bucket. This data, so now we can go ahead and create a model. So the one I want to use is here. All right, so I've selected my data set. Canvas is going to give us the option to determine what the target column is. And then if we look at the model type, it'll automatically change once we're ready. Oh, I picked the wrong data set. There we go. Smart grid data set. And we'll let that come in. There we go. We're ready to use it. So we're presented with a bunch of information about the data, and what we want to focus on is this grid stability feature. So it's a binary classification problem. The grid is either stable or unstable. You can see once I selected this target column, it automatically predicted that it is a binary classification problem. I can see information about the data set. I can visualize it. But what I really would like to do is build a model. So we're going to go to Preview Model, and it's going to build a quick model to just see, is this data even useful to predict my target variable? It normally takes about 2 minutes for it to do this, and is doing a single pass through the data to create this model. Once this is done, I can go to Quick Build and have it build a larger model. It will run multiple passes through the data, do some additional techniques like transformations of the data, and then I'll get the results. And the final option is to do a standard build. You can see here, standard build will do even more passes through the data and actually generate a Jupyter notebook that describes all the different transformations that have happened. That takes a lot longer to build. So for today, we'll just focus on doing these quick ones. Go ahead and get that quick build started as well. I'm going to go start. One of the really exciting things about the way that this works is I can run multiple things at the same time. So I'm building out this model. It's going to do a quick build for me. So we've let Canvas run and it's now finished. It's asking us how easy that was, and I'll say that was pretty easy. And the model that we've created accurately predicts the stability of the grid 97% of the time. This is a really high number, but if we look at the original data set, we'll find that it also has really high numbers. So it's just part of the nature of this data set. Find a good example there. So there we go. Using canvas to make predictions.